Hello guys, let's begin the discussion over the questions. First question says omega is a complex number such that magnitude, the modulus of omega is given to be √2. Alpha and beta are the solution of this equation. Then which among the following is the correct answer? See over here, if you talk about this particular relationship given, that is mod omega is √2. I know that mod omega square will be √2 square, which is 2. Mod omega square is nothing but omega omega bar. So you have got omega omega bar, which is mod omega square, is actually 2 in here. Now consider this equation, z square plus iota omega plus iota omega bar z minus 2 iota. Now 2 can be replaced by omega omega bar because everything is in terms of omega. So 2 is replaced by omega omega bar iota. Clear? In here, if you open this up, you get iota omega z minus omega bar z, because iota iota is iota square, which is minus 1, and you are left with omega omega bar iota, that is 0. From here, if you take out z common, you are left with z plus iota omega. From here you take out omega bar common, you're left with z plus iota omega. And therefore you have two factors popping up, which is z plus iota omega and z minus omega bar. If this into this is 0, that means z plus iota omega is 0, that means z is minus iota omega, and z minus omega bar is 0, that means z is omega bar. I am taking this as alpha and I am taking this as beta. I have to tell what among these is true. Consider mod alpha plus mod beta. What is mod alpha plus mod beta? Let's see. Mod alpha, that means mod of minus iota omega plus mod of omega bar. This becomes mod of minus iota mod omega plus mod omega. Why? Because modulus of a complex number and its conjugate is exactly the same. You know that magnitude of iota is 1, magnitude of minus iota is also 1. The modulus basically is 1. You get 1 into mod omega plus mod omega, which is twice of mod omega. Mod omega in the question is given to be √2, and therefore mod alpha plus mod beta actually comes out to be equal to √2. Clear? Moving to the next question, we have for any complex number z, minimum value of this expression, what do you think will it be? Now in here there is some manipulation required, otherwise the question is pretty easy. Here just understand that 2 iota is involved. And if you can remember the inequality, triangle inequality, you will be able to decode this expression. You can write this as z plus 2 iota minus z. Not a problem. Therefore, magnitude of this is same as magnitude of this. If two complex numbers are equal, their moduli is the same. If they have the same modulus, I know if I consider this as one complex number and consider this whole as another complex number, I can write this as less than equal to mod z plus mod of 2 iota minus z. You know that modulus of z and its negative is the same. So I can write this as mod z plus mod of negative of 2i minus z, which is z minus 2i. What are you getting is that this is less than equal to this. That means what is modulus of 2 iota? It is 2. Modulus of iota is 1, twice of iota, that means the moduli is doubled. So modulus of 2 iota is 2, that is less than equal to mod z plus mod of z minus 2 iota. Or I can say this expression is at least, this means at least. This expression is at least 2. This expression can attain value minimum 2 and maximum anything, but minimum value that it can attain is 2. At least this expression will be definitely 2. It can be greater than 2 as well, but it can never be less than 2. Therefore, the minimum value is 2, which is attained by this expression. Next question says if Z1, Z2 and Z3 are complex numbers such that modulus of Z1, Z2 and Z3 is 1 and also modulus of 1 by Z1 plus 1 by Z2 plus 1 by Z3. So this complete is one complex number. Its moduli is also 1. Then what is modulus of Z1 plus Z2 plus Z3? Now this is again, you know that sum of finitely many complex numbers is again a complex number. Now here if you try to just collect this, you have modulus of Z1 is 1, modulus of Z2 is 1 and modulus of Z3 is also 1. I know that modulus of Z1 square will be equal to 1 square which is 1, which means Z1 bar is 1 or Z1 bar is 1 by Z1. Similarly, you are given modulus of Z2 is 1, which means modulus of Z2 square is 1, that is Z2 bar is 1 or Z2 is 1 by Z2 bar. And you are also given modulus of Z3 is 1, which can be written as modulus of Z3 whole square is 1 square which is 1, which means Z3 bar is 1 or Z3 is 1 by Z3 bar. Clear? You have to talk about this modulus, right? And you are given that this is equal to 1. What are you given? You are given that 1 is equal to modulus of 1 by Z1 plus 1 by Z2 plus 1 by Z3. But 1 by Z1 is actually Z1 bar. So this is equal to Z1 bar. 1 by Z2 is Z2 bar. If 1 by Z2 bar is Z2, then 1 by Z2 is Z2 bar. Similarly, 1 by Z3 is Z3 bar. You know that conjugate of the sum is the sum of individual conjugates. So sum of individual conjugates is conjugate of the sum. And you know that modulus of a complex number is same as the modulus of its conjugate. So whatever is the modulus of Z1 plus Z2 plus Z3 whole bar, same is the modulus of the complex number Z1 plus Z2 plus Z3. And therefore modulus of this complex number is coming out to be exactly equal to 1. Fine. Moving to the next question, we have if A is greater than 0 and this equation is representing an ellipse, then A lies in which interval? Now see, for this the concepts need to be utterly clear. You are given that mod of z minus a square plus mod z minus 2a is 3. This is representing an ellipse. This can only happen if mod of a square minus 2a is less than 3. That's the condition for this equation to represent an ellipse. This means what? This means a square minus 2a is greater than minus 3 and less than 3. That is the meaning of mod a being less than r. That means a is lying between minus r and r. If you complete the square, you get a square minus 2a plus 1 square minus 1 square less than 3 greater than minus 3. This expression is a minus 1 whole square is less than 3 plus 1, that is 4, and minus 3 plus 1, that is minus 2. Now, the square is lying between minus 2 and 4. From here, I am just going to extract this much. You know that the graph of square function is what? That is the graph of the square function. Corresponding to minus 2 and corresponding to 2, I get the exact same value, that is 4. So if the square of a term is less than 4, that means here, that means a minus 1 has to be between minus 2 and 2. So if a minus 1 square is 4, less than 4, that means a minus 1 is greater than minus 2 and less than 2. The input has to be between minus 2 and 2 so that the output is between 0 and 4. Because this is always greater than equal to 0, right? If this is the case, that means a is greater than minus 2 plus 1, that is minus 1, and 2 plus 1, that is 3. I am already given that a is positive. So I am basically getting that a is not just greater than -1, it is in fact greater than 0 and less than 3, and therefore the interval comes out to be that a belongs to 0, 3. Next question says that mod z1 equals mod z2 equals mod z3 is 1 and z1 plus z2 plus z3 is 0. Then area of the triangle whose vertices are these three complex numbers is what? Let's see. If I talk about this triangle whose vertices are z1, z2, z3, I need to talk about its area. Let us talk about this side. Then we are going to talk about this side. Then we are going to talk about this side. You know that mod of z1 plus z2 whole square plus mod of z1 minus z2 whole square is equal to twice of mod z1 square plus mod z2 square. Now z1 plus z2 plus z3 is 0, so z1 plus z2 will be minus z3 plus mod of z1 minus z2 whole square equals twice of mod z1 is 1, so mod z1 square is also 1, mod z2 square is also 1, so you get 1 plus 1, which is 4. 2 into 2 is 4. Mod of minus z3 is same as mod of z3, which is 1. 1 square is 1, so you get mod of z1 minus z2 whole square is 4 minus 1. This is equal to 1. 4 minus 1 is 3, and so you get z1 minus z2 is positive root 3. So mod of z1 minus z2 is positive root 3. That means this length of this side is actually root 3. Exactly in a similar fashion, you get mod of z1 minus z3 is also root 3, and mod of z2 minus z3 is also root 3. Eventually, I am getting this is an equilateral triangle, and therefore its area is given by root 3 by 4 into side square. Side length is root 3 square, so you get 3 root 3 by 4 as your area. 3 root 3 by 4 comes out to be the area, and that's how you deal with the questions on complex numbers. Practice them nicely. That's it from my side. Thank you.